So today we're talking about the scalar products of vectors. All right. The magnitude is is the length. That's right. The magnitude is the length of the vector. Okay, and this ignores its direction. Something is like magnitude. And magnitude shares the same sign as it, that ignores its sign. What it is?
What?
Magnitude, when we represent magnitude in vectors, it shares the same symbol as something else in like math. It's absolute value.
Oh, okay.
Yeah, our absolute value ignores its sign because it'll always be positive, right? So like the magnitude of a vector v shares that same absolute value symbol, which is why it's really important to put the little notation that it's a vector. Yay? All right. So that means two vectors can be, completely different. So vector W can not be the same as vector V, but the magnitude of W can equal the magnitude of V. Yeah. Right? Yeah, easy day. All right. And if S is a scalar multiple, like for example, if you have some scalar times the vector V, then you can say that the magnitude of that thing is equal to the magnitude of the scalar, which is just a number, times, and I'm going to use x for times, so I don't want to confuse that with dot products, right? Times the magnitude of V. Yay? And a vector of magnitude 1 is called a Hey! Nice job. Okay. All right, here we go. Let's talk about the scalar product. Now, this formula is on your formula sheet. So memorizing it, it's not that hard to memorize it, but no, it'll be there for you. It'll be there for you in case you have way too much. Beautiful. P.S. Do you guys have your formula sheets?
Oh, yeah.
You do. Sweet. Okay. Dig it out and put it in this binder. Yeah, dig it out and put it in this binder. All right, here we go. So Arya's got it. If she looks under vectors, she will see the following formula in some form, right? Let's say you want to take the scalar product of two vectors. Let's say you have a vector like this. So here's vector W, right? And here's vector V. And you have angle between them. Then their scalar product is the product of their magnitudes. So vector V times vector W times sine, cosine, or tangent. Yeah! Cosine of theta. Yay. Or you can write this as vector V dot vector W, which is why it's called the dot product. Yeah. Okay. Notice that it's a scalar product, which means the result is a number. Yay? Okay. Ignore this for a second. That was not. I think I just did everything on top. Right? Be sure that you don't put a dot when multiplying a scalar to vector. Okay, so that way you keep multiplication and dot products separate. Yeah. Okay. As you know, theta is the angle between angles v and w. So if you let s be a scalar, dot, 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 if, and I'm sorry, there's not enough room in there. If s is a positive number, so if s is bigger than 0, then sv dot w is going to equal the magnitude of sv times the magnitude of w cosine theta, yay, which, if you go backwards a couple of steps, that's the same thing as the magnitude of s times the magnitude of v times the magnitude of w cosine theta. Or you can also say that s times the dot product of v times w, or v and w, yay. And a good picture of this would be something like this. Alright, so let's say you have w here, and you have sv here. Basically, if s is bigger than 0, you're going to have a nice little acute angle right here. Yay? Okay. If s is less than 0, change signs. Okay. All right. If s is less than 0, dot, 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 then you're going to have, basically what's going to happen, the only difference with this thing is, here's w, right? And this time, your angle is going to go the opposite direction, right? So this is going to be SB over here. So to measure this angle, it would be pi minus theta, because the reference angle is right here. You get it? Yeah, because the reference angle would be right here, so this would be theta, so this would be pi minus theta, because we're going all the way north. Yay? All right. And so the angle between SV and W is pi minus theta, and S is the same thing as the negative absolute value of S, because S is going, scale is going the other way. If that would make the vector go the other way. Yay? Okay. Other than that, well, since this is the case, then using all of this math, right, you can say that, yeah, you can say that the dot product of SV times W is equal to S times V times W. Now here's where the trig comes in. Cosine of pi minus theta, right? Well, cosine of pi minus theta, if you remember some of your trig identities, there you go. If you remember some of your trig identities, cosine of factors like cosine, cosine, sine, sine, right? So cosine of pi, cosine of theta minus or plus cosine something, something. When you simplify this, so you're just going to have to, like, believe me that this is math, right? since S is negative, it's going to be the negative of S times V times W, right? And all of this just simplifies to the negative cosine of, I'm sorry, this is not negative. Sorry. That's where the negative comes from. Here we go. Cosine of theta. So bring the negative out to the front, and you'd have the negative S times V times W, cosine theta, which is the same thing as S. It just brought it right back. Times V and W. Which is all. So as you can see, even the direction didn't change the vector. Yay? Yay. Okay, fine. All right. Here we go. We ready for some more facts? Here we go. If the angle between it is 0, so if theta is equal to 0, right? And we know that the two vectors are equal, so if vector W equals vector V, then you can say, because of the dot product, that the dot product of V times itself is equal to the magnitude of V squared. That's going to come back at us in a little bit. Yep. Okay. If the angle, Yep. If the angle is pi over 2, which is what in degrees? Yeah. If the angle is pi over 2, then if neither V or W is a 0 vector, then the dot product will be, anyone know? What's the dot product when two things are perpendicular? A equals 0. Very good. And that would mean V and W are perpendicular. Wasn't that on your summer sun? Yeah, it was. Yeah, it was. Here we go. Take, huh? Yeah, I will. I have all the answers for it. I'm just trying to find like a good break where we can like do that. But yeah, I got you. We're gonna do it. All right. Yeah, I will do it. Here we go. If the angle is either 0 or pi, think about 0, pi, straight line, right? Yeah. And V W is neither of them are the 0 vector, then their dot product, V dot W, is either plus or minus the magnitude of V times the magnitude of W. Because when you do that cosine part, cosine is 0, 0, cosine pi is 0, right? Which means V and W are parallel, right? Let's add one more rule to the bottom of this. Yep. Call it a distributive rule. And this one, put a star next to it. It's going to come back to us at the end. Let's say you're adding two vectors, U plus V, and then you want to take the dot product of another vector, W. Just like the distributive property, you can take the dot product of U and W and add that to the dot product of V and W. Yay? Yay! Okay. Whew. Already planning on Monday. Goodness gracious. Okay. Here we go. Basic unit vectors I, J, K. All right. Remember, I, J, K are vectors, so I'm going to go ahead and not write the vector symbol every time for I, J, K. Is that okay? Okay, that'll help. All right, here we go. Since they're all unit vectors, if you take the dot product of each thing by itself, so the dot product of I and I, you know what they equal? What's that? Almost. 51. Because I is 100.100. When you take the multiplication of it, it's just 1. Right? And then, I mean, it's the same thing, so it's like, yeah, so the cosine part doesn't matter. So I times I, J, dot J, sorry, not times, and K dot K will always equal 1. Joy. Now, what happens if you mix them? Yeah, dude. I times J or J times, or dot, sorry, K or I dot K or anything like that would just give you 0. Yay? All right, so the component form. This brings us to the component form. So if we let vector v be v1 I plus v2 j plus v3 k, and we let vector w be w1 I plus w2j plus w3k. Let's do some crazy algebra. Shall we? Here we go. Here we go. All right. If you take the dot product of v and w, okay, then you would get, all right, v1 I plus v2 j plus v3 k dot w1 I plus w2 j plus w3 k. Okay, and it's kind of like multiplication, but you just multiply the i's together, the j's together, and all that. You would have v1 w1 I, right, plus v2 w, sorry, v1 w2. Yikes. Right. Sorry. v1 w2. Oh, I dot I. Sorry. I dot I. Yeah. I dot j and v1 w3 I dot k. And then you would have plus v2 w1 j dot I plus v2 w2 j dot j plus jj v2 w3 jk. All right, and then you would also get v3, if you already know what I'm doing, just go ahead. v3 w1 k dot I plus v3 w2 k dot j plus v3 w3 k dot k. And this is why Meta's little ijk thing works. That's what happens. Yeah, this is 1, right? So this is a 1 right here. You'd have a 1 here, a 1 right here, and 1 right here. And the rest of them are zeros. So gone. Da, 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 da. So all of that, and I'm sorry that was a lot of work, but I promise you I went through it too. Here we go. It just says that the dot product in component form could also be written as V1W1 plus V2W2 plus V3W3, right? Which is the same thing as the dot product VW cosine theta. So both things can get you the dot product, which is useful because it depends on how they give you the problem. Believe it? Kind of? Okay, here we go. Kind of went over this. They're perpendicular if and only if. The dot product is? Zero. Yes, sirs and madams. Good. The angle, oh, this is another formula in your book. Okay. The angle, if you were to work out backwards to find it, would be the cosine of the dot product divided by the magnitudes. So it would be V1W1 plus V2W2 plus V3W3 over the magnitude of V and W, which was also on your summer assignment. Sure? Yeah? Okay. Here we go. That is... All right, and we're back. Here we go. Prove that those two vectors are perpendicular. Easy. Dot product, right? There we go. So when you do the dot product, it's V1 times V or W1, da 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 da. So it'd be 3 times -4 plus -2 times -8 plus 4 times -1, and that all equals 0. Therefore, dot dot dot, the vectors are perpendicular. Easy. All right, moving forward. Here we go. Find the angle between those vectors. All right, handy dandy formula. Good times. First of all, if this is V, this is W, it would be helpful to know what the magnitudes are. So the magnitude of V, do you remember how to find it?
You square all the values, add them, then square root.
Take the square roots. Good. So the first one, 1 squared plus 2 squared plus 3 squared, is the square root of 14. Yay. The magnitude of W is equal to -4 squared plus 2 squared plus 1, square root of 21. Yeah. I'll give you a moment. Can you pull out your calculator for me just to double check? Not the square root part. This one you can do in your head. But the cosine part, I just want to make sure we're on the same boat. All right. Here we go. So the cosine of theta is the dot product divided by the product of the magnitudes. So 1 times -4 plus 2 times 2 plus 3 times 1 divided by square root of 14, square root of 21. Okay, which is 3 over root 14, root 21. Right? At this point, you do not have to rationalize the denominator. This problem is calculator ready. This is obviously a paper 2 one because, yeah, it's not like the cosine of theta equals 1. No. All right, here we go. Radians or degrees? What's your calculator set at? Degrees? Okay, give me the degrees. You guys how the calculator does the fraction thing, right? Yeah, alpha y equals. Can you calculate it? 79.9?
Yeah.
I forgot the chart.
Buy this for now. I have to do it for my second block, but I'm marking. Yeah.
79.9?
Oh, we gotta load up.
Awesome. What if it was asking for radians?
What is something type?
Oh, go ahead. Times pi divided by 180, yeah. Yeah, so what did you get?
0.44.
Oh, I don't think so. So you guys multiply by pi.
Oh yeah.
There it is. 1.39. So either degrees, radians, whichever. If it doesn't say in particular on the test, then you're good. You're good. Okay. All right. Do you know how to find a unit vector? Well, let's go over it. Here we go. So a unit vector would be a unit vector of this thing would be like this must be a scalar multiple of the unit vector because unit vector is 1. So if you let v be the unit vector, right? Since it's in the same direction, then 3i plus 2j plus k must be a scalar of v. Okay. Therefore, dot, dot, dot. Everybody know the triangle? Dot, dot, dot. Yay! Okay. She did. Did she use lambda? So let lambda be your scalar of 3i plus 2j plus k. What did she use? S? Oh, is that minus k? Sorry. It's minus k. It's minus k. Okay. Did she use lambda? You know, Mary had a little lambda. Here we go. Nope, nope, nope. Okay. Okay. All right. Where lambda is a scalar, and then we're going to go ahead and let lambda be greater than 0. Right? So if you take the magnitude of that vector, and that's going to be the lambda times the magnitude of that 3i plus 2j minus k. Right? 3 squared plus 2 squared negative 1 squared would be square root of 14. Very good. Okay. Then since v is the unit vector, let me extend this bit. Faster. Boom. Oh, there it is. Okay. There we go. Since v is the unit vector. Ooh. Alejandro said it. That means no. Oh, was it Nick? Sorry, Nick. Nick said it. This is equal to 1. Thank you, sir. Therefore, lambda has to equal, we'll take a Chick-fil-A break, right? And v is equal to 1 over root 14 to 8 plus 2j minus k. All right, Chick-fil-A break. Chick-fil-A break. There we go.
She was waiting up for you.
Two more. Here we go. Let's do an IB example. Example 4. Is it not there? Okay. It's written on your paper, isn't it? Okay. in example 4, it says that, you know, OA is A, OB is B, and OC is A plus B. So if the magnitude of A and B are, show that if they're equal, then the dot product of A plus B and A minus B is equal to 0.
Junior.
Good morning, Tiger. Please pardon this interruption for example.
Oh, sorry.
We're going to be having the junior assembly at this time in the auditorium. Juniors are reminded that they should not bring anything with them. At this time, all of our juniors on Charlie Hall, Delta Hall, and 200 Hall will be dismissed to the auditorium. All of our juniors on Charlie Hall, Delta Hall, and 200 Hall should be dismissed to the auditorium.
You did. You said you couldn't go. Oh, no, there is not. I already told about that thing again. Why? My parents said I didn't even know where to go. You have 15, 16. But I gotta take a book. Good! I think 15, 16.
All right, here we go. So this is kind of the kind of finagling the distributive role we did last time. So IB, right? They give you the first half, and then you got to include out the second half. So if you use the A plus B dot A minus B and then work it out, given this part, it should work out. So here's a distributive rule with two things. Now you have distributive rule again. True? So it'd be A dot A plus, yeah, A dot B, sorry, A dot A plus A dot B plus negative B dot A, so it'd be minus, right? Okay. Yeah, minus A dot B, and then minus B dot B. Okay? These two cancel out. And remember that A and B are vectors. Sorry. So if these two are vectors, then when you multiply two vectors together, go back to the original one, isn't that just the magnitude of A squared minus the magnitude of B squared? Okay? Since the magnitude of A is the same thing as the magnitude of B, you just do a simple substitution, and you'd have A squared minus A squared, which is 0, smiley face. Done. Smiley face? I'm put a smiley face with it. Well, I'll just put one next to the 0. It'd be like the face left. Yeah, that's a good one. I like that one. Yeah. Okay. All right, last one. Here you go. In example 5, you got the triangles with those vertices. Show that AB dot AC is equal to 10. Negative 10. Okay? Since they gave you A, B, and C, we have to find A, B, and AC. Hello. Right? All right. So would you agree, unless, is there a faster way to do it? Isn't AB the same thing as OA and OB minus OA? Is that true? Right? Okay. So if you subtract their components, so what did I do? Oh yeah, 3 minus negative 1. So it'd be 3 minus negative 1, comma 6 minus 3, comma 1 minus 2. So that's going to equal 4, 3, negative 1? Yeah. Thanks, Matt. Yay? And then AC, you would do the same thing. Just subtract C minus A, and you would get...
At this time, all of our juniors in the portable music wing and gymnasium can be dismissed. All juniors in the portable music wing and gymnasium can be dismissed to the auditorium.
Did we get negative 1, 1? Is all good? Okay. Then AB dot AC, you would just multiply and then add it together. So 4 times negative 3 plus 3 times 1 plus negative 1 times 1, which happens to equal negative 12 plus 3 is negative 9 minus 1, negative 10. Joy! That's A. This is part A. Yeah? Okay. There you go. Part B says find the angle at DAC. Joy. Hi, Greg. What's up? Oh, in the back. Anyway, come in. All right. Okay. Here we go. So, there you go. You're welcome. Good morning. So let's just change that to theta, right? We also need to know the magnitude of AB, which would be the square root of 16 plus 9 plus 1. Sorry? Yeah, 25 plus 1 is 26, right? And the magnitude of AC, I'm skipping some stuff right now, but if you want me to work it out, I will. It's good? Okay. Square root of 9 plus 1 plus 1. So, you're welcome. Square root of 11. True? Okay. So again, classic IB problem. They use the first part to help you with the second part, right? Because to find the cosine, you would take the dot product, which you got was negative 10, over the magnitude. Okay? All right. Here's the answer. $126.3 degrees. Okay. All right. Did I get the ratings on it? Mark? Got this. 2.20. Ooh. Or 2.20. Rad. It's good. Okay. All right. So your homework tonight. Let me pause this video. There we go.